Hello and welcome to another Fireside Chat with the Xperts. I'm your host, Megan Bergsma, alongside Creative Electrons CEO, Dr. Bill Cardoso. So National Manufacturing Day is coming up soon. It's Friday, October 1st, and we wanted to connect this chat with the themes of manufacturing, supply chain, and of course, X-ray. Chatting with us today is an expert of manufacturing in his own right, Oliver Perez. Oliver, thanks for joining us today.
Thank you, Megan. Pleasure to be here.
Yeah. So we're going to just jump in and talk about COVID-19 pandemic and the supply chain as the first topic. So what has the COVID-19 pandemic taught us about supply chain resilience?
I can start. We were just chatting before entering into this conversation about all the limitations of going into other countries. And we, as a humans, are limited to, our transportation and also all the regulations and tests and PCR serology. But these goods and also all the supply chain got constrained all around the country, all the different countries, because it is moved by humans. We are far to be 100% automated, and we need to rely on humans, and these humans need to be available at the different points of the supply chain to move this material forward. And that is one of the main constraints. And the other one that I see is pulling a lot of inventory in advance, like a precautionary. As manufacturers, we want to be ahead. So we're pulling a lot of inventory and place them into our warehouses, and that created us a surplus, a demand, a pent-up demand that in a certain way, it is not a real demand, and that is generating a lot of stress in the supply chain, creating a lot of effects in certain economies as well.
So how do you think companies can better prepare for disruptions in the future?
In order to prepare for COVID, I think the most important element is to generate and learn about what happened these last 2 years. We cannot fall again and not have the right procedures, how to handle, for example, very simple things. At the entrance of your factory, how are you going to diagnose temperature, or how can you interview personnel that are suspicious? Because if you don't do that, you're going to have a more larger problem. So are you going to have an area for at the exterior of your facility to treat or diagnose in a deeper way, like a PCR rapid test or others, these people that are suspectful? And the other one is simple things in your cafeteria of those factories and those manufacturing areas. People need to eat. And we are social animals, right?
Yeah.
We like to be together and chat, talk, laugh, sometimes cry. And how can you secure those areas in your cafeteria in a way that you can organize the people, pulling the food, eating the food in a distance, and also preventing having the distance got reduced because of our impulse to get together. Simple visual signs, procedures, and even training for all these personnel. So there's a lot of things that need to be done. It's not just a matter of cleaning the facility every day. It is about the behavior of people in those factories.
Definitely. So taking to account the things, the systems that you want to set in place for the future for like a pandemic disruption, how do you manage a peak a peak in demand when you're working from home, when it became the norm at that time?
Well, when we're talking about a peaking demand as a supplier of goods, for example, in the medical device industry, our customers are the patients. Unfortunately, because of the COVID, all those treatments and also hospitalizations have been a little bit postponed, so the demand has not peaked as much in the medical device industry as we would like, right? But in order to prevent these situations, it's not a matter just to think about the lean thinking about pool, right? It needs to be more strategic. It needs to be more in taking into account secondary effects like COVID and also climate change. There's a lot of areas where climate change is generating a disruption on the supply chain and also on the consumption of the goods for companies like us. If you take into account the Southeast and all the tornadoes and hurricanes there, it is not just a natural phenomenon. It is also a disruption of the supply chain because the hospital needs to close. There's no electricity. And it is the same on the West with the fires. Taking into account all those disruptions, not just COVID or others, it is important to analyze the entire supply chain.
So is this the end of just in time?
Oh, it's a great question. I think just in time is just needs to be evaluated, and I would love to see the analysis of just in time with variables included for natural disasters, pandemics, and also economic flaws from certain countries that are betting too much into certain elements of the economy and they got crushed, and that generates huge disruptions. So I think just in time is one of the best tools, if not the best tools of the lean thinking, but it needs to be revamped. And also, I think I will use an artificial intelligence model to analyze what will be the impact in the inventory levels based on the probability of disasters around the world. That could be a cool project for somebody that is interested.
Yeah, it's a pretty cool project because it's the analysis based on the current pandemic, right? On itself is fascinating because it has consequences and intentional and unintentional consequences that are almost impossible to foresee, right? And what makes this even more fascinating is you try to understand what the next catastrophe, what the next pandemic is going to be, right? Mm-hmm. And you mentioned, for example, testing temperature at the gate in your company. Will the next pandemic be detected by temperature changes? Is that going to be a virus, right? Is it going to be something that temperature is not going to be any effect? So the real challenge, I think, is not, you're right. You have to design adaptable and flexible organizations, right? They can quickly adapt and restructure themselves to be able to figure out if it's temperature changing, separation at the cafeteria, extra cleaning, every, beginning, half, and end of the shift, right? So you have all these moving parts. And the challenge for us is to design organizations that can adapt quickly, right? Because you don't know what's coming up, right? If it's a tornado in a specific location that disrupts a specific component, or a pandemic here on the other side, right? So absolutely, how do you do that? And I know you wrote a book about it. Let's see if I can pull out the book. Megan, do you have the book? Or I think I have it here.
That's great.
I'm sorry. I'm going to do a blatant
plug in
of your book. It's right here. Can you see that?
Yes.
Oh, yes.
Yeah,
Thank
so this is an
you.
awesome book that Oliver wrote with a couple co-writers, Soseda and Cruz, Manufacturing 4.0, the use of emergent technologies in manufacturing. I mean, you should get a new cover, Oliver, to say in times of a pandemic.
Yeah, that's a great title. And talking about these emerging technologies and how to confront these disruptors. And you mentioned, Bill, a very important um, element that we need to have in the new organizations. And I'm not going to say only for manufacturing, but it's for the entire organization. It's
Everything. Yeah.
flexibility. So
Yeah.
how do you bring flexibility when you need to write down the temperatures of an equipment, or what time did you finish your operation, and then you need to give that to the supervisor, and the supervisor will put it in your hours for you to
Mm.
get the paycheck for the hours that you work. Or how can you optimize an equipment that is manually collected on the behavior of that equipment. So flexibility and technology are a pair of concepts that, if they are used in the right way, will provide a lot of flexibility. And one of the examples, and the best examples, is manufacturing execution systems.
Right.
Manufacturing execution systems is not a new concept. It's been as a concept developed since the 80s and even before. Um, it is part of the layer between the HMI, SCADA system, and the ERP systems, or the business informatic systems and the production systems. And what it does is, if you have the right information in the manufacturing execution system, and if you know the capabilities of your production lines, you have the schedule of production, you can move your production to the right lines and provide flexibility. If line one is down or doesn't run that per number, or it has a different capacity that doesn't adapt to your schedule, you can move it around. And that
Mm.
is the best application of manufacturing execution systems, or MES. A lot of medical device companies are using MES to move out of the paper-based EDHR, or DHR,
Mhm.
device history record, because they are using this tool to upload information automatically out of each operation, or from equipment, and then putting up a record that they can use to report the process for that specific product. Um, this is a good utilization, but MES is much more as a concept than that. And flexibility and technology using MES specifically on the production floor can provide a lot of flexibility. And flexibility as well. I mean, since we are in this topic, right? And we're saying
Mhm.
how can emerging technologies can be applicable in order to prevent disruptions or to confront disruptions. When you have an application that is based on the cloud, let's think about that. Don't give any names of any company that doing this, but you got an inspection at the end of your process, and then that inspection use a matching vision system, and it is inspecting the quality of that specific line. If you put the software in the cloud that is going to be inspecting that specific feature of your product, you can, anywhere in the world, update that algorithm and then send it over to the station that is inspecting that, and
Mhm.
you provide flexibility. If the engineer of that facility in that factory cannot get into the company because of COVID, or because there was a tornado or something, somebody in another facility anywhere in the world can update that algorithm and send it over to the station that is inspecting that feature, and problem solve. That's how technology can support flexibility and confront disruptions of any nature. And those are just examples that we can
No,
discuss.
that's fascinating. And I love the idea that MES allows you to, the flexibility not only, within a plant, but geographically, right? So that you can optimize manufacturing between San Diego, Oregon, Singapore, Taiwan, right? And you have the digital twins, right? They can replicate that manufacturing line, and which leads to quite a bit of optimization, right? So that you can figure out what's the best product at the specific time, specific conditions of the supply chain, and specific geography. Because what we find now is that, like you've witnessed it, right? The connected world we lived in might not be as connected as we thought, right? Our ability to move from place to place got interrupted, and it's been interrupted for almost 2 years now, right? So I think, and what I love about your book is that you wrote that before the pandemic, right? So it was like a roadmap or how to do it, So when you have a disruption like that, you can still keep the manufacturing line working despite the geography impediments. And so, we talked about, the ability to provide some centralized intelligence on the cloud, right? Where you can see inspection, you can see supply chain from a somewhat central location. It doesn't matter where the location is, but if you think of a artificial intelligence engine that's looking at these different locations, right? Geography, the different geographies where the plants are. Can you envision an algorithm that would be able to forecast disruptions before they happen by looking at, for example, oh, look at this. This 100 nanofarad capacitor went from 4 weeks to 10 weeks lead time in this location. That's interesting. So do you envision an ability to forecast disruptions, by collecting information and data from all these different geographies?
Yes, the answer is yes. There's already a lot of projects from different companies, big companies that are in the artificial intelligence domain that are already working on this. For example, IBM and the product Watson, I think is the name from IBM. They are already predicting where the next tornado is going to be, when the next disaster is going to happen, based on the world temperature or climate. We should better say climate conditions. So you can use that information and fit it into other we call it towers, visual towers that companies like Flex is developing or developed already, where you can see not only where your boats or your merchandise or your goods are in the middle of the ocean, but you can pair that with the IVN model that predicts how the climate is going to be, and you can determine changing the routes, or you can determine delays, or you can determine situations that are going to impact your supply chain. They are also models that are integrated into that analyze oil factors, like, it's very expensive, the oil for the next 3 weeks. So how that is going to impact your price, the cost of your goods that are, once again, in the middle of the ocean.
Exactly.
There's climate change, there are economies, climate, and there's also even social events in certain countries that can have a repercussion on the cost and lead time of the goods that you need to provide to your manufacturing facility. So yes, there are already some products in the market. Unfortunately, they are super expensive at this moment. But as anything in technology, we have a tendency to extrapolate in the short term and then kind
Yeah.
of disregard in the long term what is going to happen. The prices of these visual towers are going to standardize and they're going to flat and they're going to be more accessible. But there are products out there that you can use.
Yeah, I mean,
Bill.
there's what we see is a democratization of technology, right? So over time,
Yeah.
thanks to video gamers and cryptocurrencies, those things get cheaper and cheaper every day.
And
Sorry, Megan.
Oh, no worries. I found that very interesting. Are there systems in place, Oliver, that kind of, since Bill and I are in California, we need to worry about fires and earthquakes? Is there systems in place that I don't know if there's even systems in place that can detect when fires happen? I think that's fault by human beings, but how about earthquakes?
um,
Earthquakes, you can tell after they happen very reliably.
yeah.
Before.
I think there's, I don't know if it is 10 seconds or up to a minute that we can predict
Yeah.
that an earthquake's going to hit on your location. But I don't want to disregard the importance of, being in compliance. You have to, double check your center of gravity of all the equipments, double check if you need to chain them or if you need to, anchor them correctly. I don't want to disregard and pass the message that,
Yeah.
predicting and then reacting. Uh,
Yeah.
it is better to do all our diligence and put those equipments earthquake proof. And also, yes, if we are able to make good use of those 10 seconds or a minute that we're going to be ahead, yeah, it's good. But let's do it the right way from the beginning.
Exactly. Hopefully, you don't have to save equipment; just save yourself, right?
Yes.
So, one part of the conversation that's intriguing me here is the dichotomy between efficiency and flexibility, right? Because we see a lot that it's a compromise sometimes, right? I mean, we're not pitching flexibility, but oftentimes flexibility comes at a cost, right? You might not have the most efficient piece of equipment because it has to be flexible, it has to change or adapt, like a Swiss Army knife, right? Swiss Army knife has every function, but it's not good at anything, right? It's not a good knife, it's not a good scissor, but it can do everything, right? In your, you've had an amazing career at different medical device companies. How have you been able to, how do you approach that, right? From a strategic perspective, how do you approach this compromise in your, in your in a daily basis?
This is a great question. Um, Let me start by saying how flexibility came into manufacturing specifically. When we came out of, or still in the mass production, we had that famous phrase from Mr. Ford. You can have all the colors of the car that you want, with the only, but it needs to be black, right?
Exactly.
Because I mean, they cannot provide flexibility to the mass production they had. When we start to evolve from there, we start to create more and more diversity of the products. And when internet came into the hands of the user, they became a dictators. They wanted their product. They wanted fast. They wanted the color they
Yeah.
wanted with the feature they wanted. And that created such a number of configurations that translated into manufacturing that it was so rigid coming out of mass production without being able to accept all those configurations and different elements that they needed to produce. They created like a constipation. Let's call it
Right.
that way. was a
Yeah.
constipation of manufacturing because of the requirements and demands of the customers. How it got solved is still not solved completely, but
Correct.
software as an element of flexibility became to be a very important tool. We did talk about MES. We did
Mhm.
talk about moving elements of your uh, data, scheduling, production, inventories to the cloud that are accessible across all your supply chain that can help you to take decisions on time in order to prevent this famous constipation of manufacturer, right? Um, but we are still there. We still need to provide even more flexibility to the local level of the operation. And this is what I mean. When we are dealing with a transformation of the raw material into a good, which is the definition of manufacturing,
Right.
what we are doing it in automation is to provide a big asset that is going to do a lot of things to that raw material and make a subassembly or a finished good. Unfortunately, those big assets are not flexible enough nowadays. They have a lot of technology. They can
Correct.
do it faster. And as I just said, they bring a lot of efficiencies, but
Yes.
they are not flexible enough yet. So what
Mhm.
we need to do is to start working with more technology that can provide that flexibility. What are these technologies? For example, you can use collaborative robots that are programmable in 10 minutes. Okay. They are portable. You can move that collaborative robot to different stations and hand teach that robot. You move the arm, you make a pick of something that you're picking, and then you put it in another place, and then you run it.
Yeah.
Before, 10 years ago, it was a, a super engineer that it was coming out of the Ivy League that had to code that industrial robot in order to do the same. So now we got this opportunity, but this is at the local level of the operation. Other things is, using all the AMRs that are available to move material. And now you can provide materials to different lines, and you are not constrained by the person that needs to understand the schedule of where to deliver what material necessarily. You can MES can talk to the AMR, autonomous mobile robot, and deliver the material to the right production line without human intervention and providing the flexibility that we need. So those are the advantages that we can use the technology for. But I, I cannot emphasize enough, we're still far away, at
Yeah.
least at the operation level of the transformation process of manufacturing, to bring more flexibility,
Yeah.
because the customers are expecting, fuchsia products, purple, black, white, and we need to provide that diversity and in the goods, by
Yeah.
increasing flexibility at the manufacturing side.
Yeah. Some time ago, I read an article saying that one day, I think the forecast is by 2020, we would all have 3D printers in our house. And if you needed a part, instead of going to Home Depot, you're just going to push a button and print,
Mhm.
a new toiletry fixture, right? For your toilet. And needless to say, that hasn't happened, right? And I know additive manufacturing is a whole new conversation we can have. But, in whatever time we have left, give us your insight, right? I mean, it's one of those technologies that went through the Gardner curve of the huge excitement and then the valley of disappointment, and now we get into maybe a level of, okay, this is what it can do, this is what it can't do, right?
Mhm.
What's your take on it?
I think it is a transformational technology.
Mm-hmm.
Um, it is a something that is still being adapted for different situations. The big concern is to find the right cost or breaking cost point,
Mm-hmm.
where in the curve of your cost analysis versus volume, you are going to be better in terms of cost versus a molding, for example. If you are in a high volume type of environment, it will be not well advised to try to replicate that with a 3D printed technology. But if you are in the low volumes and a lot of configurations, you are definitely in better position to use 3D printing than using molding. One of the advantages of 3D printing technology, one, you move from a digital model to a physical model in an instant. Okay. Yeah. You don't go with the middle of creating a mold or a casting process in order to create the final product. So you move from your slicing model to the physical element, and you can use it immediately. Who is the best who is the best function within manufacturing that can benefit from it? New product development, R&D. Those are the areas where you need to iterate a lot of new designs, and definitely 3D printing found a house in R&D and NPD for sure. The other areas that if manufacturing is prohibited because you have medium to high volumes is on the spare parts. If you have a strategy around spare parts using 3D printing, you can reduce shutdowns of your equipment, shutdowns on your production lines by reducing the lead times. Sometimes the supplier will take 3 weeks, 4 weeks, and you can provide that spare part in hours. The other element is, when you are facing customers and you are in the marketing function, you are promoting certain elements of your products, you can deliver those solutions in a rough way, let's say, with the 3D printed product and obtain immediate feedback instead of waiting, I don't know, probably months to have a good finished product that you can submit to the customer to obtain feedback. There's a lot of advantages. Another one is, that manufacturing, there's a lot of jigs and fixtures. We use a lot of in production. We use a lot of anchoring, a lot of jigs for everything. Yeah. So 3D printing is a good tool in order to provide quick solutions, prevent shutdowns, and improve your processes, trying and testing new ways of fixturing your elements of production. So those areas are very good for 3D printing. But the most important one, from my perspective, is in R&D and NPD, because now you can dream. 3D printing is complexity free. You can create shapes and forms that are impossible in molding, and that gives you more versatility. You can go far and beyond in your designs.
Sky is the limit. Yeah.
Yes.
I think it's a good part to end there, Bill. I
think we'll have to bring Oliver back, because that was awesome conversation. And I got you asked 2 questions only. So thanks so much for your time, Oliver. It was absolutely awesome.
Thank you so much.
And we look forward to the follow-up to your book, right? Manufacturing Times of a Pandemic.
Manufacturing 5.0. There you go. Have your title already.
Good job.
Thank you, guys. It was a pleasure. Bye-bye.
Bye, Oliver.